One of the most powerful techniques in scientific experimentation today is algorithmic design of experiments. In this video, we're going to show you how to construct and apply such a design directly to your Riffyn experiment. We're using here fermentation process as an example experiment. It runs from inoculation of media to fermentation to sampling, dry weight analysis, optical density measurement, and analytical chemistry. In this case, we'd be interested in optimizing the nitrogen sources and concentrations used in the media. So here we're taking a look at the fermentation step, and we see that the default nitrogen source is ammonium sulfate at 5 grams per liter with a range from 3.5 to 6. The inoculation step also has a nitrogen source. In this case, it's urea with a different range from 2 to 3 because the molecular weight of urea is about half that of ammonium sulfate. What we'd like to do is tweak these, see if choice of different nitrogen source in either the inoculation or the fermentation step might deliver better outcomes. So to do that, we're going to make use of an add-in for Riffyn we've built for JMP. We choose JMP because it comes with powerful custom design tools for DOEs. So to get started, first select from the Riffyn add-in for JMP the Create DOE for an experiment. And this opens up a modal which asks for your login and your experiment ID. And you can see it's already populated with an experiment ID. That actually came from this experiment here, where you can just copy paste the ID directly from the URL. And if we flip back, and we just paste it into that, and then click OK. What this is going to do is go out into the experiment and fetch all of the properties that exist on that process. So here we have this modal which shows us every property on every material input or output across the entire process. So we're going to first look for the inoculation step, and we're going to pick the nitrogen source type and the concentration and set those as properties we want to include in our DOE. And then we're going to the fermentation step and we'll do the same thing. The type and the concentration, and then click OK. What that does is it calls JMP's custom design tool, and it pre-populates your experimental design with the specifications from the experiment. Here we see urea on the inoculation step and a range from 2 to 3, and ammonium sulfate on the fermentation step with a range 3.5 to 6. So we want to change this by adding urea and ammonium sulfate across the two steps as alternatives. So first we'll add a level to the inoculate media, and we'll add ammonium sulfate. And then we'll do the same for the fermentation step, but this case we'll add urea. We're going to keep the ranges there because those are the default ranges we've had to date, and might as well start by testing those extremes. So for now, you just click continue, and this generates the next step in the DOE wizard in JMP, which gives you an opportunity to modify the design parameters. We're just going to accept the defaults and click make design, and then this generates a run table of all the mixtures and combinations of urea, ammonium sulfate, the high-low concentration ranges of each for each of the steps. So from this design, we just click make table, and that generates a design table in JMP, which we can now use to populate onto the Riffyn experiment. So typically, you'd have to manually type all this information into your experimental plan, but we can save that automatically to the Riffyn experiment, generating the runs as we need them. To do that, we open up the add-in again, and we click Write Plans to the experiment. It again asks for your API login credentials, and if you've already entered them, they're already saved there for you, and you click OK. And now it's writing those run parameters to the experiment. It takes a few seconds to do, so we'll just wait a moment. And now it's finished. So the DOE was successfully created. We click OK. And now if we go back to the experiment, we are on the inoculate media step. If we look at the actuals, we'll see that it's actually populated a set of runs right onto the experiment for us. If we scroll across, we can see that the runs now contain ammonium sulfate and urea in different use across the different runs with different concentrations chosen for each of those. And we also see, if we click the batch fermentation step, that it too has been populated with ammonium sulfate and urea with different concentration values. If we look across all the other parameters on the experiment, they're all set to their default values from the specifications, from the target specifications. So next what we'd like to do is connect these 12 runs here from the batch fermentation step to the inoculate media step. So we use this flow mode in Riffyn, which allows you to see the runs on both steps at the same time, and we'll select the runs on the fermentation and the runs on the inoculate media, and then click the go button here, which will connect the runs one-to-one to each other. And now we can see that the runs between the two steps are connected. And if we scroll across, we can see now that the full DOE across these two steps has been populated. So here we have urea at 3 grams per liter and urea at 3.5 grams per liter across the second run in this process. And if we go back to JMP and look at the design table, we can see that the second run on the experimental design was in fact urea with 3 and urea with 3.5 grams per liter. So that concludes our demonstration of Riffyn's DOE design tools.